Well, hello guys and welcome back to Mr. G Physics, the channel that is going to help you to improve your marks in physical sciences. This is Mr. G, and this time we're going to be solving a question for the grade 12 related to rate of reaction. It's a very important topic for the upcoming exam. But before we move on, don't forget to subscribe for the channel so you can get the notification of all the videos I post. This question says dilute acid indicates that in the table below react with excess zinc in each of the three experiments to produce hydrogen gas. The zinc is completely covered with the acid in each experiment. So you have experiment 1, 2 and 3 and you have dilute acid. So from the table, you can see that in the first experiment, they use 100 cubic centimeter of 0.1 mole per cubic decimeter. In experiment 2, they use only 50 centimeter of 0.2. So they used less, but the concentration is greater at this specific point. Okay, so this is the main thing here. Experiment 3, they repeat with the same one as experiment 1. The volume of hydrogen gas produced is measured in each experiment. So they record the volume of the gas that is going to be produced in this specific experiment. Name 2 essential apparatus needed to determine the rate of this hydrogen production. Now, how will this setup be done? Well, the first instrument for sure is the stopwatch. You need to measure time. This is one setup that can be done here. No necessarily need to be like this one. Here, for instance, we have a gas syringe. This is a gas syringe. All right, this is one example. This one here is a conical flask. Conical flask. That is one example of a setup that can be done to collect the gas, because all the gas is going to move all the way through and is coming to the gas syringe that can be measured. This is one example of collecting the gas. The other one is to using water displays, like in this case here. Also, we have a conical flask. We have tub with water, this instrument here with water. This measuring cylinder will be filled up with water. The water will be all the way up, and as the gas is going to move into the measuring cylinder, the water will be displaced. This method was shown to you previously to collect the gas. So it's another way of measuring the gas here. So guys, this is one method. You can use that one. So those are 3 of the instruments that you are going to use. The graph below was obtained for experiment 2. So this one was for experiment 2. You know that this one is the product. This is the volume of the gas form. So you need to know that this one represents the product. All right, so let's move on. The question says use this graph and answer the questions that follow. First question, at which time T1, T2 or T3 is the reaction rate the highest? Guys, the reaction rate is going to be the higher at T1. Now, the answer is T1. Why is the reaction rate higher at T1? Because it has a steeper gradient. Alright, you need to know that the gradient of the graph will represent the rate of the reaction. At this specific point, the gradient is the highest. Look here, if you represent the gradient in each point. Anyway, the one that is closer to the y-axis will give you, or will be the one that have a greater rate of reaction. The next question, at which time is the mass of zinc present in the flask the smallest? Well, guys, when the experiment is done, remember this part of the graph represents completion. So there is no more reactants. The reaction is done. So in this case, which of the 3 times will have less amount of reactant? That will be T3. That one is quite simple. So here is T3. This is quite simple question for you to get good marks. The next one, in which time interval between T1 and T2 or between T2 and T3 does the larger volume of hydrogen gas was formed per second? Well, all right, so that one will be between T1 and T2. All these ones are quite simple. How do I know that? Because they ask the largest volume of hydrogen gas formed per second. That is rate of reaction. So it is going to be between T1 and T2. That is greater volume of the gas formed per unit time. That one is the question. That is quite simple. Question 8.4. Redraw the graph for experiment 1 in the answer book. On the same set of axes, sketch the graph that will be obtained for experiment 2 and 3. Clearly label the 3 graph experiment 1, 2, and 3. Very, very good question. So we are going to do it right here next to the table and next to the previous graph. Okay, we're going to use the same set of axes here. We don't have to redraw here, but now we have to look carefully. There is a little bit of tricks here. First, they use sulfuric acid in experiment 1 and 2, but they use hydrochloric acid in experiment 3. They use the same amount, but is hydrochloric acid, the same concentration, but still is another acid. So let's do experiment 1 and 2. Experiment 1 is already represented. You have already experiment 1. I'm going to just erase these lines here because I want to draw here in the same graph the experiment 2. What happened with experiment 2? The concentration is great. The amount of dilute acid or sulfuric acid used is less, but still is covering the other reactant, which is the zinc. So it means that you still have enough to produce. So all is going to happen here is that it's going to be produced at a greater rate. So this graph will go all the way here, a little bit closer to the Y, and it will end in the same place. Okay, let me see if I can make that graph to look better. It go all the way up here and it will end in the same point here. This one will represent experiment 2. This blue line is experiment 2. Now experiment 3 is a little bit tricky because we have a new acid. Okay, and everything is coming from the chemical reaction. Here is the two, or they are the two chemical reactions. The first one is the zinc with the sulfuric acid, and the second one is the zinc with the hydrochloric acid. Now, where the issue comes? The issue comes at this point here. For the second reaction, to produce the same amount of hydrogen, you need double the amount of the acid with hydrochloric acid. You can see it there. In the previous one, the ratio is 1:1. But in the second reaction, you need double amount of acid to produce the same amount of gas. Or you need, in this case, you will be producing, if you have the same amount of gas, it means you will produce half the amount of gas. I hope this one is clear. It's a little bit tricky because you need to write the reaction for you to understand. Otherwise, it's very confusing. You can see here by the ratio, to produce the same amount of gas, you need double the amount of acid. But they didn't use double the amount of acid. They used the same amount. It means that you are going to have, the graph is going to be very much similar to this one, right? It's going to be very much similar to this one in terms of the gradient, but is going to be stopping before the other one. It will produce only half the acid. This one is experiment 3. I hope this is clear. This is a very, very good question. Everything is coming because of the reaction. I hope you understand what happened in this part of the question. Let's go to the next one. It's the initial mass of zinc used in each experiment is 0.8 grams. The balance equation for the reaction experiment 3 is this one here. Okay, we already did write the reaction there for you to see. Calculate the mass of zinc present in the flask after completion of the reaction. Now, know the following. If they are asking you to calculate the mass of the zinc present at the end, it means that not all the zinc was reacting. So there is some leftovers in here. All right, so we cannot use this mass right away because that is the mass of the total zinc. But some zinc reacted and some zinc stays behind. What we can use is the concentration of the acid because that one was completely used. One of them was completely used. It means the acid was done and there was still some zinc behind there. All right, so here we are going to do the calculation. So the first thing we have to do is to calculate the number of mole of what we know, which is the concentration of the hydrochloric acid and the volume. Alright, here is the data, but we have to convert cubic centimeter to decimeter cubic. Guys, you divide by 1,000. That one will give you that is 0.1 decimeter cubic. Alright, so now we are going to calculate the number of mole of this that is known by us. So the number of mole here is equal, let's write the formula of concentration. Concentration is equal to number of mole divided by volume. This equation is going to be given to you in the exam. So go there, don't memorize it if you think you're going to forget. Now this one is 0.1 is equal to the number of mole we're looking for divided by the volume, which is 0.1. So the number of mole is equal to 0.01 mole. This one is for the hydrochloric acid. Alright, this calculation we've done here is for the hydrochloric acid. That is the amount of hydrochloric acid that was used. Okay, so for this one, we need to use the ratio. So we're coming back to the equation and we look at the ratio of hydrochloric acid and zinc. And that will give us the amount of zinc that reacted. You can see that is 1:2. So we're going to write here the ratio. Okay, work organized. Ratio of Zn to HCl. Those are the two I want to look for. So the ratio here is 1:2. 1 for zinc, 2 for hydrochloric acid. We use 0.01 mole of hydrochloric acid. I want to know how much zinc was used during this reaction. Guys, if you think you're going to get confused, you do a cross product here. Alright, it's quite simple this one because it's half, but you can do the cross product there. And this one will be 2x equal to 0.01. It means x is equal to 0.01 divided by 2. Let me rewrite it properly here. 0.01 over 2. Okay, and this one is going to be equal to 0.005 mole. This is for zinc. This is for zinc. This is the amount of zinc that is being used. So using this one, we can know now what was the mass of zinc in there. Alright, with this one we can use now the mass of zinc that was used. So from here we go to number of mole is equal to mass divided by molar mass. This is for zinc. Alright, so number of mole 0.005. Mass, we know we're looking for that one. The molar mass of zinc, you go to the periodic table, guys. That one is 65, and then the mass is going to be equal to 0.325 gram. This is the mass of zinc that was used during the reaction. They want to know how much is left. Well, this one is simple math. You have that the total mass, this is total, let me write it, total is equal to mass used plus mass left. Okay, that is the total mass. Total mass is given to us in the question. It is going to be 0.8. That one we know it here. So this one is 0.8. The mass used was 0.325. How much is left behind? How much is left behind? Let me write it here. Left. So it's 0.8 minus 0.325. Mass left is equal to 0.475. 475 grams. This is the answer here. And I hope it's clear. I hope you understand what to do this calculation of stoichiometry. Now, question 8.5.2, how will the mass of zinc present in the flask after completion of the reaction experiment to compare to that answer to question 8.5.1? Write down only larger than, smaller than, or equal to. And guys, it's the same as the previous question. We have to come back here to the two equation. To use the zinc, you need a double amount of acid in reaction 2. So we're speaking now about the reaction of the sulfuric acid in this case here. So in this case, In this case, you need now double amount of hydrochloric acid in order for you to get or for you to use that zinc. So in this case now, guys, we are going to have a smaller than. So the answer here is smaller than. I'm going to just highlight it here. The answer is smaller than. You need to use you need double amount of acid to use the same amount of zinc. Okay, so I hope you understand. This is a very good question for the exam, guys. I hope it helped. If it helped, thumb up, subscribe for the channel. Next time I'll see you with another video. Mr. G here.